All right, so if you tried those two exercises, well, the first one was really pretty easy, probably. For the reverse wedges, you just need to, for the upside down wedges, you need to count down instead of counting up for the inner loop and outer loop. For the reverse wedges, the trick is to print one less space than the counter and then print the character. So that's a couple ideas that you can use to help you if you had a challenge with that. Now, as far as swapping two integers, or two anything for that matter, you need to understand before you do that, probably your challenge was that you tried to pass those two integers. You knew that inside the function, the values were getting swapped, but outside the function, they weren't getting swapped. So you might have had some thoughts about that, but let me tell you what's really going on. By default, when we pass a parameter to a function, we are passing the value of that variable, the value of that parameter. So let's say if a equals 2, and we say that we're passing a, we're not passing a, we're passing 2. So the value of the variable is passed instead of its actual variable, or instead of the address. This is called pass by value, and it is the default behavior of function parameters. Changing the value, therefore, of a variable inside the function does not change its value outside the function, even if those two variables have the same name. This is because the parameters passed to a function are local to the function only. They have what we call local scope. They don't have global scope. And they are local even if they have the same name outside the function. So if we have a parameter, let's say b, that is passed to a function, and if we pass b outside that function to the function, and then inside the function we call it b, they are two different variables named v. So when you tried to swap a and b, let's say, when you came out of the function, a and b were two different variables than they were inside the function. All right. So here's an example. It's kind of analogous to what you were trying to do with the swap function. So in the main function, let's say that we have an integer a equal 1. And we have a function someplace called add. And what it does is it adds a variable, or it adds the number 2 to a variable. And it's defined as add int a, int b. So here I'm just adding 2 to a. And then if I print, no matter what I do inside add, this is just going to print 1. If we look at the function definition, though, we have void add two integers, a and b. If we say a plus equal b, inside the function, if we print that, it'll print 3. But even after we call add outside the function, it's still going to print 1. Why? Well, because a is 1 outside the function. Doesn't matter if a is 423 inside the function, it still retains its value outside the function. This is the behavior passed by value. Now there's another way. To change the value of a parameter that we pass into a function, to keep it, to retain its value outside the function, we don't pass the value, we pass a pointer to the value. And this is why pointers are so important in C. This is often called pass by reference. Now, if you know C++ or you know some other language where you know the keyword or the kind of entity name reference, this is not the same thing. In C, a reference is an address. So pass by reference means pass by address in C. We are passing a pointer. In other words, we're passing the address of a variable to the function rather than just its value. Therefore, changes to the contents of that pointer, star, persist after the function returns. So this is how we can change values. This is how, for example, hint, hint, we can swap two values and retain their swapitude or their swappiness or whatever after the function returns. So here's an example. Again, it's the same example we had before. So in the main function we have a equals 1. Now let's look at the add function here. What are we doing here? We are adding a pointer to A and B. So if we say the contents of the pointer A plus equal B equals, or if we say the contents of A plus equal B, that means that here, when we come into the function, A is going to be 3, and outside, when we print it outside the function, back in the main function, A is also going to be 3. So if we pass a pointer, we pass the address of A, then we can change the value of A, in this case. And generally speaking, if we pass a pointer to the function, we can change the value or the contents of that pointer even outside the function. All right, some things to note about pointers and functions. First of all, generally, the name of an array, without the square brackets, is a pointer to the first element of the array. Just accept that. That is the way it is. The name of a string, a char star variable, is a pointer to the first character in the string. Just accept that. It is true forever. You cannot pass an entire array to a function, but you can pass a pointer to the array. Remember that. That's extremely important. You will try, probably, down the road, to pass an array to a function. You can't do it, but you can pass a pointer to an array. What am I saying here? You can pass the name of the array. You cannot return an array from a function, but you can return a pointer to that array. And, finally, modifying an array or a char star inside a function modifies the array or char star outside the function. Think about the 5 statements I've made on this page, and then think about why this last statement is true. Thank you.